Shown is a right-angled triangle. We need to determine the length x. To do this, we're going to use right-angle trigonometry. This is our right angle, then this is our hypotenuse, this is our adjacent, and this is our opposite. So here we have something about the adjacent and the hypotenuse. So we're going to deal with cos of 62 degrees is equal to x over 7. So we multiply through by 7 to get x is equal to 7 cos 62, which we calculate to be 3.29. Hence, determine the length of y. There are several ways we could do this, but given that it says hence, I'm going to use Pythagoras' theorem. Pythagoras' theorem says that y is equal to the square root of 7 squared minus that 3.29 squared. I'm going to use the answer button in my calculator rather than 3.29, and I get 6.18 out of that. I could also have done that using trigonometry, knowing that sine of 62 degrees is equal to y over 7, so y is equal to 7 sine 62, and when you evaluate that, you get the same answer. Now we're going to think about what happens to the lengths x and y if the angle increases. So if this angle gets bigger, how is that going to affect x and y? So for that angle to get smaller, that means that this point here is going to move up, which means x would have to get bigger. If this angle gets bigger, this point here is going to move down, which means x is going to get smaller. Alternatively, y could get smaller, which would mean when this angle gets smaller, or y could get bigger, and that would increase this angle. What about the right angle? If the right angle was to change, what would happen to those lengths? Let's assume that the 7 centimeters here stays the same this time. So if this point was to sort of move inwards in this direction, then this angle would become greater than 90 degrees. If that was to happen, these two lengths would both get shorter. If, on the other hand, this was to move away from there, this angle would get smaller, and x and y would both get bigger.